Alright, we're going to continue with 20D, enlargements and reductions. So this is from your textbook. It says the diagram below shows the enlargement of triangle PQR with center point C and a scale factor K equals to 3. P prime, Q prime, and R prime are located such that CP prime, so this here, CP prime equals to 3 times CP. So CP was this. So basically, CP times 3, that's the length of CP prime. And then CQ prime is equal to 3 times the length of CQ. So as you expected, right? So this is 3 times the size of this. And of course, the CR prime is 3 times of a CR. So it's the same thing. Okay, and then the image P prime, Q prime, R prime has sides which are 3 times longer than those of the object PQR. So here, it's nothing new. If you need to review this, that's okay. That's what we're doing right now. We learned this in grade 8, enlargements and reductions. We called them dilation. So these are the same thing as dilation. Okay. Reduction, as it says, is to reduce the size, right? And then enlargement, saying you are enlarging something. If you're into photography, I can talk today. We're enlarging the picture sometimes to make a poster, or if you are reducing the image, right, to fit the camera even, or just, you know, making wallet size pictures. So there are stuff like that. Okay, so let's try it out here to review your memories. It says consider the triangle ABC with vertices with these coordinates here. Find the position of the image of triangle ABC under, we're going to explore an enlargement and a reduction. Okay, and then these examples give you center 0, 0. And then the scale factors are represented by K. So as you guys can see, enlargements, K are greater than 0. For reduction, K is between 0 and 1. Okay, not less than 0, because less than 0 is negative. I don't even know what that means if you're reducing with a negative number. So it's between 0 and 1. Alright. So I plot the points and labeled them. And we're going to enlarge it first with center 0, 0 and a scale factor of 2. So this is what you do first. For enlargements and reductions or dilation, your center of dilation does not matter. Okay, unlike our rotation, as long as you point where the center of dilation is and then find the distance of that, then you're good, right? So in this case, let me do O to A here. So 1, 1 and 0, 0. How do we find the length of this? Pythagorean theorem. This is 1, 1. A squared plus B squared, that's 1 plus 1, so this is square root of 2. Okay. And then I'm going to measure A to B here, O to B here. And this one here, the leg is 1 and 1, 2, 3, 4. So 4 squared is 16, plus 1 squared is 17, so square root of 17. Let me write those down. So OA is square root of 2. OB is square root of 17. And OC is 1, 2, 3, 4, and 1, 1, right? So this is 1, yes. So that's the same thing as b, square root of 17. Okay, let me erase all of these. Can get messy sometimes, and that's okay. Alright. So okay, so they say to enlarge this triangle, so this is our triangle, okay, to enlarge it twice its size, because the k is equal to 2, right? So we expect OA prime would be twice the size, so 2 times square root of 2, and OB prime is equal to twice the size of square root of 17. OC prime is also 2 square root of 17. Okay, so here are the things that you can do. So can you guys see that A is 1 unit away from the x-axis? So let's do twice its size, right? So twice its size would be 2, 2. So this would be A prime. So what I just did was, since A is 1, 1, then A prime would be 2, 2. Okay. We're increasing the distance here from the origin. Okay. And then B was 4, 1, and then we're going to enlarge it. So B prime, 4 times 2 is 8, 1 times 2 is 2, so 8, 2 is right here. You guys can see it visually, right? Because it is, the distance is twice right now. Okay, and then last but not least, C is 1, 4. So C prime is 2, 8. Again, this is twice the size here. Can you guys see that the image, all of these points of the image goes through your original points, right? Or your pre-image points. So yeah, alright. Let me draw the triangle here, the new triangle. So this would be your image. Alright. So for, as you guys can see, it grows twice the size, right? And I measured the distances here for you to check. I'm not going to do it on this video, but you can check it yourself. You can find the distance between all of these points, but here was what I wanted you guys to take away from this video. When you're enlarging something from the origin, you just multiply the coordinates here by your k. So for reduction, that would mean you have to divide by 2, right? Or multiply by 1/2 for each of these coordinates. So yeah, there you go. So this is the summary. And again, for dilation, if your center of dilation is somewhere else, let's say it was like right here to -7, you just have to do the same thing. Do this, right? So from this point to A, what's the distance for that? And then you just multiply that distance, whatever this is. So let's say this is A, multiplied by K. So would be twice the size, right? So you go up. All right, that's it. If you have any questions, let me know. These are all review from grade 8. It's been a long time, so that's okay. See you guys.